Hello, welcome to Anatomy and Physiology audio series learning module number 10. This module covers the subject of blood pressure. In addition to this learning module this week, you should also read chapters 17 and 18 in order to be prepared for class. Keep in mind that information in these learning modules are always fair game for exams, and you may or may not have a quiz over this material when you get to class next time. So when we talk about blood pressure, just sort of a key concept to keep in mind is that what actually increases and decreases blood pressure, because there's really only two things that increase or decrease blood pressure. If you think of a blood vessel as a water balloon, so you just think of it as a water balloon. If you fill the water balloon up with a lot of water, that's going to increase the pressure on the water balloon, right? If you keep filling it up, it's going to increase the pressure. If you deflate the water balloon, if you let water out of the water balloon, that is going to decrease the volume of water in the water balloon, and that is going to bring pressure back down. So one thing that increases or decreases blood pressure is a change in volume. So the more volume you have, the higher your blood pressure, or higher the blood pressure. The less volume, the lower the blood pressure is. The other thing that affects blood pressure is an external force. So if you squeeze the water balloon, if you took the water balloon and squeezed it, that would increase pressure. If you relaxed your grip on the water balloon, that would decrease pressure. So the squeezing of the water balloon versus the releasing of the water balloon is analogous to blood vessels constricting and dilating. So if you constrict a blood vessel, if you squeeze it, that's going to increase blood pressure. If you release your grip on the blood vessel, that is a decrease in blood pressure. So two main things that happen at the blood vessel level to increase or decrease blood pressure is an increase in volume will increase blood pressure, or what we call vasoconstriction, or constricting the blood vessel, will increase blood pressure. What decreases blood pressure? Less volume in the blood and a relaxation of the blood vessels, or dilation, vasodilation. So blood volume increases when you have a lot of water in your blood, or when you have a lot of salt in your blood and water follows, okay? Because of osmosis, water is going to follow salt. So if you have a lot of salt in your blood, then water is going to enter the blood as well. So those are two mechanisms that can raise your blood volume and thus increase your blood pressure. So if you have a lot of fluid in your blood, or if you have a lot of salt in your blood and therefore you have a lot of fluid in your blood, both of those things can increase blood pressure because that's an increase in blood volume. Vasoconstriction increases blood pressure, and vasodilation decreases blood pressure for the reasons we just mentioned. Okay, so if you're vasoconstricting, that increases blood pressure. If you're vasodilating, that decreases blood pressure. Okay, there are two mechanisms that control your blood pressure. So this is homeostasis once again. You have to stay, a healthy body needs to stay within a certain range, right? If your blood pressure gets too high or too low, this can cause all kinds of health issues, right? Because of homeostasis, the blood pressure needs to stay within a certain range, and your body's going to work to keep your blood pressure within a certain range. And there are two systems that control your body's blood pressure: the nervous system, which we've talked about extensively, and the endocrine system, which we also talked about extensively. These two systems control your blood pressure. So we're going to talk about how each one controls blood pressure. So this is nervous control of blood pressure. Nervous control. and I believe I've mentioned this before, but we'll go over it again. Baroreceptors. Baro means pressure, like a barometer. It measures pressure. Baro means pressure. Baroreceptors are pressure receptors in the walls of the carotid arteries. Remember the carotid arteries, they carry blood to the brain, right? Carotid arteries have little baroreceptors in the walls of the carotid arteries. These are receptors on the dendrites of nerves that are embedded in the carotid arteries. And those receptors carry that information to the brain stem, specifically, not the part of the brain called the brain stem, which you should already be familiar with. The brain stem sends signals to the smooth muscle of the blood vessels to dilate or constrict in response. That's simple. This is called the baroreceptor reflex. This is an autonomic control, right? You don't have control over this. You don't have voluntary control over this. And it involves the smooth muscles that are in the blood vessels, in the arterioles and the venules and the arteries and veins. It is autonomic, and it involves sympathetic and parasympathetic fibers. Okay, so there is a constantly. This is constantly happening, right? It's like the blood pressure goes up. The baroreceptors tell the brain, oh, blood pressure is too high. That sends in information to the blood vessels to vasodilate and decrease the blood pressure. Okay, if the baroreceptors detect that the blood pressure is too low, they'll send that information to the brain. The brain will tell the blood vessels to constrict, to raise the blood pressure back up. So this is homeostasis, constantly going on, right, to control the blood pressure in your body. Constantly happening, right? And this is autonomic. This is sympathetic and parasympathetic, okay, that are working together to make this happen. Okay, so that was a discussion of nervous control of blood pressure. The actual mechanism is pretty complex, so I don't want to go too much into it, but you should just be basically aware what a baroreceptor is and what it does. All right, so from now on, we're going to be talking about hormonal control of blood pressure. Also pretty complicated. You're not responsible for knowing all the little details here, but you should know that this is a hormonal control of blood pressure. And there's a little system in your body called the renin-angiotensin-aldosterone system. It's a mouthful, I know. And it involves the liver, the lungs, the adrenal glands, and the kidneys. So all 4 of these organs are working together to control blood pressure. So this is another mechanism of control of blood pressure. So basically this is how it happens. The kidneys produce a hormone called renin in response to low blood pressure. So this is an endocrine function of the hormone. So the key here is that the kidneys are responding to low blood pressure. So if the kidneys are producing renin in response to low blood pressure, that means that the kidneys want to ultimately, that renin, what ultimately renin is going to do is raise the blood pressure back up. Because if the blood pressure is too low, homeostasis tells you that now you want the blood pressure to come back up again. So kidneys are like, oh no, the blood pressure is too low. Produces a hormone called renin. Eventually, there's a bunch of stuff that happens in between. Eventually, the aldosterone is then released because of the renin. Ultimately, the aldosterone is released from the adrenal gland, and this causes the cells in the kidney to retain sodium and excrete potassium, to hang on to sodium. Water follows the sodium, resulting in an increased blood pressure. Notice that the other effect, if you look at the diagram, is vasoconstriction, which also increases blood pressure. So the end result is that blood pressure is increased. Renin eventually causes aldosterone to be released. Aldosterone raises blood pressure. The arterioles vasoconstrict. This raises blood pressure. So ultimately, this entire system here the goal of it is to raise the blood pressure back up because the kidneys initially detected that the blood pressure was too low. Another hormonal control, ADH, which we talked about a little bit when we talked about the endocrine system. ADH is produced by the posterior pituitary gland, and once again in response to low blood pressure. ADH causes vasoconstriction, which increases blood pressure, and also causes cells in the kidney to retain water, thus increasing blood pressure. ADH stands for antidiuretic hormone, so it prevents urination. So in other words, instead of urinating all that water out, you keep that water in your system. That increase in volume increases blood pressure. So that's another mechanism by which blood pressure is controlled. These hormones, ANP and BNP, are secreted by the heart. Once again, these are hormones. This is an endocrine function of the heart in response to high blood volume. Okay, so blood volume is too high. If blood volume is too high, that means blood pressure is too high. So if blood pressure is too high, then the homeostatic mechanism at work is to lower blood pressure, right? So ANP and BNP cause vasodilation and also block aldosterone and renin, which prevents aldosterone and renin from raising the blood pressure. So also, by blocking aldosterone and renin, this increases the amount of sodium that's lost in the urine, and thus you have the results of the vasodilation and the loss of sodium is that blood pressure decreases. So, ANP and BNP are hormones released from the heart that cause a decrease in blood pressure. Okay, so that was it. See, nice short one. And a lot of information, of course, but short. So in summary, there are hormonal mechanisms that control blood pressure. There's also nervous mechanisms that control blood pressure. The mechanisms that increase blood pressure include the release of the hormone from the posterior pituitary gland, ADH, the release of the hormone renin from the kidneys, the release of aldosterone, a hormone from the adrenal gland, and baroreceptors in the carotids, and also there are baroreceptors, I didn't mention this, in the aortic arch as well. So keep in mind that they're not only in the carotid arteries. And those baroreceptors detecting that blood pressure is too low. That ultimately results in the blood pressure being increased. And that's nervous control. These decrease blood pressure. ANP and BNP being released from the heart decrease blood pressure. And baroreceptors detecting that blood pressure is too high in the carotids, in the aortic arch, sending that information to the brainstem, ultimately resulting in blood pressure coming down. So these mechanisms, hormonal and nervous mechanisms, work together to control blood pressure. So there's going to be a quiz on this when you get to class, and of course everything in here is fair game for the test. All right, see you next time.